This is John Black, Super Chemist. That's a nice, easy video. I'm just letting you know something about what I'm doing. Um, First thing is about me amending videos. I'm going to give you an example of one of the videos that I amended, or I'm going to as soon as I get done with this video. How to make nitric acid, fuming nitric acid. Here's the formula for it. In the video, here's the molar masses, right, or volumes, right? This is what I should have got. In the video, I did 1 mole. You know, I like to do 1 mole or whatever, right? Just like the equation. So I should have got 42 milliliters. I usually get 21. I usually get a 50% yield, okay? 50% is terrible, okay? So when that happens, what I do is each time I make it, I try to think of a new, something different I could do to maybe help that yield, all right? So I just got done making some nitric acid, and I did a lot better, okay? I needed 3 moles. So since I assumed that I'm getting 50% yield, I made 6 moles. So I times everything by 6. That'd be 336 milliliters of sulfuric acid, 606 grams of potassium nitrate, and I would get 258 milliliters of nitric acid. Of course, at 50%, right, I'd only make 129 milliliters. But this time, I added in another 144 milliliters, or whatever it is, to get me up to 500. This time, instead of adding 336 milliliters, I added 500 milliliters. Why? Well, my reasoning was this. First of all, there's always a big chunk of salt in there. When this reacts, it makes this, and so you have this salt plus a little bit of that salt in there. It's just a big chunk of, you know what I mean? It gets in the way. I don't like it. The other thing is at the end of the distillation, you have this big rock of salt in there that's soggy as heck. You can't distill it to dryness. You know what I mean? Let's say you do this reaction. Now you have all this in there. You have the salt and it's soaked with HNO3. How are you going to get all the HNO3? You can't get it all out. You know what I'm saying? Because if you do, you'll end up cracking your glass. You know what I'm saying? And the other thing is at the very end, when there's mostly this salt and only a tiny little bit of this salt, right? And there's only a tiny little bit of this, because it all got transformed, half of it got transformed into that, okay? Now, this has to find it, you know what I mean? It's not just luck by throwing it on there. You have to actually find this molecule before you can make the nitric acid, you know what I mean? The more you use up, the harder it is for these two to find each other, right? So my way of thinking was this. If I throw the extra sulfuric acid in, there'll be double, instead of 1 trying to find 1, you'll have 2 trying to find 1. A lot easier to find each other and react to make that last 50% of your nitric acid. The second reasoning was maybe this will be soluble in this, so that if I throw this in and it all reacts, I'll have an extra 140 milliliters of sulfuric acid in there. Maybe, and once it's heated up and I'm distilling this out, maybe it will all turn into liquid instead of having a big chunk of rock in there. You know what I mean? And I was right. Because I put that extra bit in, a fraction of the way into the distillation, everything melted. Everything dissolved and became one liquid. You know what I mean? There was no solids. You know what that means? A lot easier for these to find each other. You know what I mean? This guy ain't going to be stuck, a molecule stuck on a, here's a rock of salt, your potassium bisulfate. You got 1 molecule of sulfuric acid over here, and all the HNO3 is over here. All the potassium nitrate is over here. They have to touch each other. But if it's a liquid and it's boiling, that means they're turning around, getting jumbled up. You have no solids getting in the way of these two finding each other, okay? So what was my yield? My yield, instead of 129 milliliters, which is what I usually get, it was 240 milliliters. I almost doubled what I got. That's almost double. 120 times 2 is 240. That's almost double. I went from 50% to a 93% yield. Why? Because I added in a little bit. This stayed the same. The potassium nitrate. I was supposed to put this in. That's what I put in. So I put in an extra 144 milliliters of sulfuric acid. That's for 6 moles, though. Here, let me do the calculator here if I have. Okay, so that's 164 milliliters I added in extra. Okay, divide that by 6 moles. That is 27 1/3. Say 27, 28 milliliters extra I added in for every mole. So my original video, see here where I got the 20%, I got the 50% yield, I only got 21, 22 milliliters or whatever I got. What I should have done, instead of adding 56 milliliters, I should add 56 plus 27 1/3, right? Here, let me add that in there, plus 56. That would have been, I should have added 83. I probably would have added 85 just to even it out. 85 milliliters of sulfuric acid. And I bet you $1 million it would have improved this yield, because at the end, instead of having all nitric acid and you can't distill it to dryness, I'd have a little bit of sulfuric acid in there, right? I could distill all this out, still have that extra sulfuric acid in the round bottom flask so it doesn't break my flask, so I can get more out. Not only that, it would have dissolved everything, and everything could have mixed up easier. These two could have connected up easier than they do with a big chunk of solid in there. With a big chunk of solid, they're not going to touch each other out, the whole time. I bet I could have got my yield up. So anyways, this is what I'm talking about when I say amend. So since I did this, right, now I just started this, so there's only maybe 1 or 2 videos that I've done it to. But I'm going to go back to the video that's labeled how to make red fuming nitric acid. And I'm going to put this, what I just told you, I'm going to put in text in the description under the video, in the description of the video. And it'll say, hey, I tried this new method, this new way. I got a 93% yield instead of 50. My whole point and moral to the story here is that if you are trying to do something that I'm doing in a video, first of all, you should ask me if you're not experienced. I'll help you with anything. Second is you should look at the description under the video to see if there's a better method that I found to do it, like this. Also, I'm going to put this in the discussions part of my channel. Okay? When I find a new method, I'm going to go to that discussions part. I'm going to say, hey, I found a new method. This is better. Add a little bit more sulfuric acid, and you'll, instead of getting 50% yield, you'll get 93. You know what I mean? So you can also go there to the discussions, and that's all that'll be in the discussions is, just once in a while I say what I'm doing. I tell if I got a better method or something. Now, because I did add that extra sulfuric acid in, this was the pot. You can see it's still got some of the stuff in it, pre-sipped out when it cooled down to, this is room temperature now. This I used because I figured I wanted better separation with the nitric acid if I'm having, that much extra sulfuric acid in there. If you notice in my video on how to make red fuming nitric acid, I don't use a Vigrex. I just whatever, because it's all mostly nitric acid or whatever. I'm thinking, but I use the Vigrex column, so keep that in mind. And the second part of this video is about my extra videos, okay, or extra video, I call it. Some of my videos, right, at the end, I always have that thing that comes up. It'll say, always remember, science is great, and then it'll say, John Black, super chemist, in red. And that means that's the end of the video, right? That's like my logo at the end. Sometimes if you watch past that, I'll have another thing that comes up where there's text and it'll say Jbsc extra video, and then I actually put some extra video in there that has nothing to do with the video. Like I made I can't think of an example, but I might make sulfuric acid in the video, but my extra video is about, you know, I got a new torch or something. I'm showing off my torch, or I'm showing this that I got, or, you know, something like that. It has nothing to do with really the video. It's just extra stuff I'm throwing in there. Or sometimes it's just tips on, you know, being a home chemist. You know, if I make a crystal that looks cool, you know, I might put it on an extra video at the end. So I'm just telling you, it's just in case you go to the end, you've been going to the end of the video and you haven't really been paying attention. Sometimes there are like little Easter eggs. You know, if you're a video game person, you know what an Easter egg is. Some of the videos do have Easter eggs now at the end of the video. And again, if you have any questions about any of the videos, if you can't find something, you know, there's a lot of videos, just ask me. I might not have it, but I might know someone that does, and I can tell you where their video is. You know, I'm here to help and talk about science. I love chemistry. So anyways, I just wanted to just know that I do amend these videos that get terrible yields like this. You know, sooner or later I'll do the experiment again because I will need that chemical, and I will try something new. You know what I mean? Because I'm not going to settle for no 50% yield. That's crazy talk. 93%. Now that's a good yield. There you go. You know what I mean? I'm happy with that. I ain't even going to screw with that. So anyways, I just wanted to let you all know. You all have a great day, and always remember, science is great.